This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com. I showed you how we measured the risk, but yet again, he'll give you the standard deviation, but you know what we're talking about. Bigger standard deviation, more risk. But again, we can't decide which is better of those. It depends on the individual. However, think about investing in shares. Forget projects, everything for the minute. But if you were investing in shares, I keep saying, clearly you're prepared to accept some risk. Obviously shares are risky, returns go up and down. But you'll accept risk provided you're getting a big enough return. Okay? However, the point I started to mention before break is if you were investing in shares on the stock exchange, there are ways of certainly reducing your risk without losing return. And that has to be bad. If I can get the same return with less risk, clearly that's good for everybody. Yeah? And to show you what I mean, it's very quick and it's a very baby one, but then we'll do a proper one. Can you look at example 3? Example 3. It says the following are the likely returns from investments in ice cream and in umbrellas. Now I say it is really a baby one, but I'm trying to make the point. I've said the return from ice cream depends on the weather. That if it's sunny weather you sell more and you get a return of 20%. If it's raining you sell less and you get 10%. Yeah? You see the logic? In most countries that's reasonable. Here people seem to eat ice cream whatever the weather, but you take the point. But the point is, if you do invest in ice cream, obviously there is risk. And it says calculate the average return and the total risk. Well, the average return, of course, you can write straight down almost, but this is ice cream. Your return's either 20%, 15% or 10%. The probabilities, here it's a third each time, it's equal. Well, surely I don't need to go through a multiply. Would you all agree here, but shout if you don't. Since they're all equal probability, isn't the average going to be 15%? Would you all agree here? If you don't, there's your homework at lunchtime. Do it and check it. So the average return is 15. Clearly there's risk. You might do better, you might do worse. Well, it only takes 2 seconds here. The difference is you either get 20, which is plus 5 on the average, or you get 15, the difference is 0, or you get 10, compared with averages, minus 5. You still with me? Well, to work out the standard deviation, again, to average those, you'd get 0, it's silly. We square them. And we take the weighted average, multiply by the probabilities. So here I am actually wasting your time, but it's very, very quick. But 8.33, 0, 8.33. Am I right? And that is the variance. The standard deviation, we take the square root. I get 4.08. All right? So I say, I'm wasting your time. I keep saying you will not ever be asked to do that. But it was so quick here, I don't really care. But that investment, however babyish, you'd be getting an average return of 15 with a risk of 4.08. Okay, everybody? However, there is an alternative here, that you could invest in umbrellas. And of course, umbrellas, they give 10, 15, 20, but it's the other way round. Same probabilities. Well, surely I don't need to write it all up again. Would you all agree that the average return from umbrellas, again, is 15? And would you all agree, without writing all the workings down again, that even though they're the other way round, that the risk, the standard deviation, again, would be 4.08. And so if you had to choose between the two, then, of course, you'd be indifferent. Same return, same risk. It wouldn't matter. However, and I hope it's so obvious it's not true, even if there are only two investments here available, they're both risky. Here, you could get exactly the same return of 15%, but you could remove the risk completely. And the way you could do it, remember, we're assuming you're buying shares. Surely, if you invest 50% of your money in ice cream, and 50% in the other, well, I'm sure you can spot it already, but the point is, do shout if I'm not making it clear, but if it's sunny, surely if half your money is getting a return of 20 from ice cream and half your money is getting a return of 10 from umbrellas, surely on average you're getting 15%? If it's cloudy, half the money's getting 15, half the money's getting 15, surely you're getting 15. If it's raining, again you're getting 10 on half your money, 20 on the other half. Again, overall, you'd be getting 15. And of course, the average return, you're still getting 15%. But would somebody like to tell me, what's the risk, the standard deviation? Say again, Natalia? That's 0, surely. There is no way I'm going through the arithmetic. But if you end up getting 15%, whatever happens, your risk is 0. You've managed, with two individually risky investments, by mixing them together, you've managed to remove the risk. Clear? Now, of course, that was an extreme example, clearly. In real life, you don't find such a perfect situation. But I think you'd agree, the reason that's happening, I know you can see at a glance, but it's because the two investments are sort of moving together, but in opposite directions. It's because of the way, I think you've heard the word, the way they correlate together. Correlation? Yeah? That because they move in exactly opposite directions, and it's a perfect match, we were able to completely remove the risk. In real life, that doesn't happen. You never find investments that are perfectly negatively correlated. But, even so, potentially, you can only reduce the risk to 0 in this perfect situation. But potentially, by mixing two together, you're potentially able at least to reduce the risk, if you understand me. Now here it was all very easy, but there is a formula which you're given in the examination where if you are mixing two investments together, with different risks, where we can work out the total risk of the two together. All right? And you've got the formula. It's on the formula sheet, but I've printed it on page 33. that SP equals, and I hope I've used the same symbols, I've just had a little panic. Have I used the same symbols as him? What? Have I? Oh, good, sorry. Anyway, there's that little formula, which looks messy, but in fact it's very easy, except, of course, you've got to remember what the symbols mean. But when you mix two investments together, SP will tell you the total standard deviation of the combined. All right? Well, let me illustrate how the formula goes with example 4, and then you can try one. Excuse me. Euris currently has a portfolio of shares. Now, listen to this. Read it carefully. Euris currently has a portfolio of shares. So he's a portfolio. He already owns some shares. But at the moment, he's getting a return of 20 with a risk of 10. Okay? We're considering a new investment. And it's going to give a return of 20 and a risk of 12. All right? However, hello? I'm not choosing. I'm not saying to you, which will I prefer? If I asked you to choose between the two, you'd prefer, they both give 20, so you prefer the one with the lower risk, clearly. But what our decision is it worth adding it to our portfolio? So we either stay as we are, in which case the return will be 20, risk of 10, or we add this new one, and we've now got, if you like, two together. Clear? Well, my decision, of course, will be based on the risk and the return. But if we do add the new investment, with the new investment, first of all, what will be the average return if we do take the new investment? At the moment, I'm getting 20%. If you take the new investment, what will happen to my average return? It'll stay the same, surely, because deliberately I've chosen the new investment gives 20 as well. In general terms, had it been the case that we're giving different returns, would this make sense? Now, the very last sentence says, the new investment will be 40% of our enlarged portfolio. And so surely, if we do it, 60% of our money is in the existing. Yep. And the existing is giving 20%. The other 40% of our money is in the new. Would that make sense? So whatever returns I'd given you... Hello? Yeah, it's obvious here because it's the same, but whatever returns I'd given you, surely the overall return will effectively be the weighted average. Here, as I say, it stays at 20, and quite deliberately, because since we're going to end up with the same return, the decision here is going to be based purely on the level of risk. We know at the moment our risk is 10%. If adding on the new one, if the risk's high, we won't do it. If the risk's low, we will. And so we will need to work out what the risk is if we take the new investment. Well, here's where you've got the formula. So just check with me. You're clear what symbols are, what's going where. SP, which is the total risk of the two together, all right? It's the square root of that huge thing there. Well, in that formula, SASB, they're the individual standard deviations of the two things we're mixing. You with me? WA, WB are the proportions in each. So perhaps I better write down it was WA squared SA squared plus WB squared SB squared. I'll write the rest in a minute. But it doesn't matter which way around you do them. But if A is our existing, the proportion in the existing is 0.6 squared. The standard deviation of our existing is 10 squared. Everybody? Plus, if B is the other one that we're adding, the proportion in the other one, WB, is 0.4 squared times the standard deviation of this other one, which was 12 squared. So I'm not being insulting. I know you can all use calculators, but are you all clear so far what the symbols are meaning? It's plus 2, that's a number, times WA, WB, the two proportions. So the proportions, it was 0.6 in the first, 0.4 in the second, times, and I'll say more about this in a minute, but the coefficient, I beg your pardon, I haven't written up, it's 2 WA, WB, RAB, SASB. It's times, well, RA is the coefficient of correlation between the two investments. I'll say a few more words about that in a minute, but I think you've all heard of that somewhere. But the coefficient of correlation is what? It's plus 0.2 times SASB, the two standard deviations. The two standard deviations are what? 10 and 12. Now, if you're worried about coefficient of correlation, I'm going to say a word or two in a second. But in terms of putting figures in the formula, all right, you've got to remember which is which, obviously, but otherwise, are we clear? Obviously, it's then just arithmetic. Be careful, but can somebody check me? But then you can. I'll write each term separately. But 0.6, 10, 36. Yeah? Okay, but of course that's just calculator work. The main thing is, right? Alright, before I make any comments here, excuse me, correlation, I said, I think you've all heard of it. You can't be asked to calculate coefficient of correlation, so if anybody's never done it or forgotten it and worried where it came from, by all means ask me and I'll sit down with you later, but the exam can't ask you to calculate it. But I think you should all be aware that the coefficient of correlation measures how well two things fit together, if you understand me. And, be honest with me, whether you remember or not, I think you should note that if two things match perfectly and they're going up and down together, the coefficient of correlation is +1. That's perfect positive correlation. And what that would mean, if you think back to my ice cream and umbrellas, if you got one giving 10, 15, 20, if the other one was giving 10, 15, 20, yeah? Well, they match perfectly in the same direction. Whereas -1 coefficient of correlation is perfect negative. And that's what we had in our ice cream and umbrellas. That, you know, one went up, the other went down. Again, I hope I'm making sense. And of course, that was the ideal situation. That when they matched exactly in the opposite direction, we were able to remove the risk completely. Okay? Now again, I said in the real world, clearly, you don't have ice cream and umbrellas, you know? You're not going to be able to remove the risk completely. The coefficient of correlation will never be -1. But what's terribly important here, you can only remove risk completely if you have -1. I think that makes sense to all of you. I hope I've made that clear. Yeah? In the real world, it never is -1. You can't remove risk completely, but you can still potentially reduce the risk. All right? And a lot of people say, oh, all right, we accept it won't be -1, but they say, oh, as long as it's negative, we can reduce risk. If it's positive, we can't. Well, that's not the case. And I'll tell you why in a moment. But look at my example. This is why it took me ages to make one up. You're going to have to believe, obviously, the formula's true, you know. It is. I'm not going to waste time proving it. But just look at this example. At the moment, we are getting a return of 20 with a risk of, what was it? Was it 10? We had a new investment which gave the same return, and it gave higher risk. These two investments were positively correlated. It was plus 0.2. So they're obviously not moving perfectly, but they are moving up and down together, if you understand me. There's no sort of going the opposite way. And yet, by mixing the two together, there's no way we can reduce risk. You could only remove risk, rather. You could only remove risk if it was -1. But the two together, same return. But even though we had 10, we mixed with an even riskier one at 12. Mixing the two together, here we've managed to reduce the risk down to, was it 8.4? And so is it worth taking the new investment? Of course it is. Yeah? If you get the same return with less risk, obviously. But I actually think that's important. I mean, for the exam, all right, you just make sure you can use the formula and then write, yes, it's good, no, it's bad, sort of thing. But do be clear, because it leads on to the next little bit. Sorry, before I write it, you see, the reason I think that's important is in real life, if you're buying shares, sorry, I will write that down in a second. But if you're buying shares on the stock exchange, they're all risky. Share prices go up and down, returns go up and down. They all tend to be positively correlated. Because when the economy does well, all shares tend to go up. When it does badly, they all tend to go down, you know? But to different degrees. But in real life, you don't find umbrellas ice cream. But even when you've positive correlation, you're potentially able to reduce risk by mixing. I say potentially, it doesn't always reduce, you know. I had to invent figures that made it work. But that is important for what's following. That even with positive correlation, we are potentially able to reduce risk by I'll use the posh word later, but for the moment, by mixing investments together. Now, for the pure numbers, irrelevant, you know. It's easy, the numbers are easy. You can always use a calculator. I'll show you an old exam one later. You can have a go at home. But he had to do it 3 times, basically. But it was simply using the formula. So, I mean, a bit of practice, but no problem. But for any discussion at all, and for what follows, if you mix investments together, the risk you end up with depends on, obviously, the individual risks and the correlation. But, sure you understand that although the correlation would have to be -1 to remove risk, with any level of correlation, you're potentially able to reduce risk. Okay? And that has to be worthwhile, clearly. If you can reduce risk without hurting return, clearly that makes sense. Okay?